During a football game, a punter punts the ball from 3 feet above the ground with an initial velocity of 128 feet per second. And they give us an equation that models the pathway of the ball. Graph the function. We want to label the vertex and the intercepts. Okay, so here's our graph. And this is not going to be drawn to scale, but we are going to include these things. All right. This is time in terms of seconds. And this is distance in the air. And it's in terms of feet. So I can see that the ball leaves the punter's foot 3 feet above the ground. So I'm going to graph that intercept at 0, 3. Then I'm going to use the calculator to do the rest of the tough stuff. I'm going to plug in the equation that they provided us with. And I'll graph it. Now I need to adjust the windows. So I'm going to go up, and we're going to start with 100 and see if 100 is high enough. And getting closer, but clearly not. Let's try 200. Still not there. I'll go to 300. And that will work. I still have room up here, but recognize there's like no room down below when I have to answer some questions. So I'm going to stop, and I'm going to go to Windows, and I'm going to change the Y minimum to be like a -50 or -60. Just make sure you have some room down here. Okay, so what else do I have to graph? I graph the y-intercept. That means I need to graph an x-intercept and the vertex. X-intercept and a vertex. Let's start with the vertex. This is a maximum value. Second, trace maximum. Follow the directions, left bound, right bound, and guessing the highest point. So if I go over 4 and I go up 259, okay. 1, 2, 3, 4, and again I'm just estimating this is 4 and 259. So I've done the vertex, I've done the y-intercept, now the x-intercept to get credit for part A. I want to know this value. Second, trace, we want to find the x-intercept, also known as the 0. Left bound in this case means above the x-axis, somewhere above, press enter. Go somewhere below, press enter, and back up to the x-axis as close as you can, being on top of it. And I'm going to round to the nearest hundredth here. I don't see any directions what to round to, but I'm going to do that to be safe. Here's 5, 6, 7, 8, 8.02, and 0. I follow the direction. I graph the function showing the vertex, showing the intercepts of the y-intercept and the x-intercept, and I've labeled both lines. Now, when we learned this last week, it often said things like when the ball is descending, at what time is the ball descending and hits a certain height. This does not say whether it needs to be ascending or descending. It just says at what moments is it 115. So pretend this is about 115. I want to know at what 2 moments does it hit 115, and those moments are going to be in terms of seconds. So if you go to your graph, go to y equals, and go to the second y sub 2, type in the value they provided, which is 115, and hit graph. I can see it intersects the graph in 2 places. So I want to know what are those places. To find those values, please do second trace intersect. Second trace intersect. Okay, so it says first curve. That just means one of the functions. So I can see, I can move the cursor. It's on one of the functions. In this case, it happens to be the parabola. I press enter, and it will jump to the next function, which is right here. It's my horizontal line. I press enter again, and now it says guess what the intersection point is. So I go over the top, and I press enter. What does this mean? This means that after 1 second, the ball is 115 feet in the air. So I know one answer is 1 and 115. Now I want to find the next one. I want to find this one. Again, same thing. Second trace, intersect, press enter. I'm going to have the first curve be the parabola. I press enter. It will jump to the second function, which is the horizontal line. Press enter. And then it says guess. That means go over the top of the intersection point, guess where it is, and press enter. This means after 7 seconds, the ball is again at 115 feet above the ground. So at what moments is the ball at 115 feet? 1 second and 7 seconds.